Welcome to the next module of MCQs on Basic Properties of Waves Part 3. Students, let us have a look at the first MCQ. The frequency of a tuning fork is 220 Hz and the velocity of sound in air is 330 meters per second. When the tuning fork completes 80 vibrations, the distance traveled by the wave is option A 100 meters, option B 120 meters, option C is 140 meters and option D is 160 meters. Let us have a look at the solution, students. So we have clearly given m is equals to 220 Hz. Also we have velocity is equals to 330 meters per second. The next step, very quickly, which formula connects V and N? Yes, it is V is equals to N lambda. So students, the value of lambda is going to be 330 upon 220, which is equal to 1.5 meters. This comes after cancellation as 110 3s are is 330 and 110 2s are is 220. Now students, just have a look at what are we supposed to find. We are supposed to find the distance traveled by the wave in 80 vibrations. So here I raise a question. What is the distance traveled in one vibration? Yes, it is exactly one wavelength. So if we calculate the wavelength and multiply it by 80, then we will get our answer. So students, let us go ahead. We know that lambda is going to be 1.5 meters. When the tuning fork completes one vibration, the distance traveled is lambda. So very clearly, distance traveled by the wave in 80 vibration of the tuning fork is going to be 80 into lambda. So now we just have to calculate 80 lambda, that is nothing but 80 into 1.5, which comes to 120 meters, and thereby option B becomes our answer. Students, let us have a look at the next question. In a medium, sound travels 2 kilometers in 3 seconds. 2 kilometers, distance. 3 seconds, time. And in air, it travels 3 kilometers in 10 seconds. Once again, 3 kilometers, distance. 10 seconds, time. We are supposed to calculate the ratio of the wavelengths of the sound in the two media. Options are A 1:8, B 1:18, C 8:1 and D is 20:9. Now students, let us have a look at the solution. Vm, that is velocity in the medium, is going to be distance upon time. So it is nothing but 2 kilometers in 3 seconds. So 2 upon 3 kilometers per second. Let us have a look at the next. VA is equals to, what is VA going to be equal to? VA going to be equal to 3 kilometers in 10 seconds, that is 3 by 10 kilometers per second. So students, we have lambda m upon lambda a is equals to question mark, that is we are supposed to find this ratio. Now students, very important, for a given wave, frequency remains the same in all the medium, that is n remains constant. So in the formula V is equals to N lambda, if N is constant, we get V is directly proportional to lambda. So we will be using this particular relation to solve the rest of the MCQ. So here we go. If V is directly proportional to lambda, then lambda m upon lambda a is equal to Vm upon Va. That is why lambda m upon lambda a is equals to 2 by 3 upon 3 by 10. We are just substituting the value of Vm and Va. This is equal to 2 by 3 multiplied by 10 by 3. 3 and 3 cancel? No students, hang on. 3 and 3 is not cancelled. The final answer is going to be 20 upon 9. And that is why option D is going to be our answer. Let us go for the next question. A sound wave of frequency 20 Hz covers a distance of AB of 300 meters in 10 seconds. What is the number of waves between A and B? 100, 150, 250, 200 are our options, students. Let us have a look at the solution. Students, we have n is equals to 20 Hz. So further, if I am taking A and B, the distance is going to be 300 meters and the time taken is going to be 10 seconds. Now students, we know that speed is equals to distance upon time, which is nothing but in this particular case 300 upon 10, which is equal to 30 meters per second. So students, we have got the value of V and N. Let us go ahead and find out lambda. So we have V is equals to N lambda, that is lambda is equals to V upon N. So finally we get the value of lambda as 3 by 2 meters. Students, we know by calculation that number of waves in 1 meter is going to be equal to 1 upon lambda, which is represented by nu, which is also known as the wave number, students. So if we have the number of waves in 1 meter, can't we have the number of waves in 300? So in 300 meters we will have this particular equation, that is equal to 300 into 1 upon lambda. So students, the next step is going to be 300 into 1 upon 3 by 2. So further if I calculate, it is going to be 300 into 2 by 3, and the final answer, students, is going to be 200. So this is the final answer, and the correct answer is going to be option D. Thank you, students.